Back of the cabinet. Only the 4th week of school. Alright, so again, all of them tell you concavity. All of them. And this one can tell you the y-intercept because if I put 0 in for x, these first two terms are gone, and I'm just left with c. So standard form, what can you determine? Your y-intercept, which is c. It kind of looks like a little frowny face. Angry. The angry human too. Alright, what about factored form? This is a tough one. Remember, factored form looks like this. Ax minus r1, x minus r2. Isn't that what they say the r is? Yeah. Do you remember what those r's are? No. But that's a good guess, because it does start with r. This one is like roach and reel. Ransom, yeah. Rainbows. They're roots, okay? They're roots, also known as x-intercepts. Factored form tells you your x-intercepts. And your x-intercepts will be r1 and r2. Why do we have two x-intercepts? Yeah, it's parabolic. It curves and it either goes up in two different places or it goes down in two different places. Parabola. Alright? This is a tough one. In vertex form, what can you automatically get in vertex form? The vertex, yeah. And the vertex is HK. You can also tell the axis of symmetry because anytime you know the vertex, you know the axis of symmetry. I will probably never write axis of symmetry again. It will be AOS. But the axis of symmetry is at x equals 8. When you get that written, go over to page 97. Can I move this? Can I erase it? No, a couple people are still writing. No, they're like 15. Alright, a little background. So Christine and Kate are about to, like, fight, okay? Because they were asked to determine the vertex form of two different quadratic functions. Each one, no, not the vertex form, sorry, just the vertex. Two different quadratic functions, each written in different forms, and so these are their calculations, okay? Now, see, they both got a thumbs up, so that means they're both right. In the book, if somebody gets a thumbs up, they're right, and a thumbs down means they did it wrong, okay? So watch for those. Anyway, but they didn't do it the same, but they both got, they both did it. They got the thumbs up, so they're right. So Christine had, what form is Christine's in? Standard form. So the axis of symmetry, this is the formula for axis of symmetry in standard form. This is so super important. X equals a negative b over 2a. That's super, 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 super important. So what Christine did is she found the x for the axis of symmetry. Now remember, axis of symmetry passes through what? The vertex. So if she knows the x-coordinate of the vertex, then all she has to do is plug that number into the problem, and she'll have the y-coordinate of the vertex. So she got that negative 3, because that's a negative b, so it'd be negative 12 over 2 times a. A is 2. So negative 12 over 4 is negative 3. So that's what she did. And then she substituted that in and came up with 8. So the vertex is at -3, 8. Okay, so Kate over here has a different function. Kate, what form is hers in? Factored form. And she has the x-intercepts, -3 and 7. And she knows that the x-coordinate of the vertex will be exactly in the middle of those two. Like if you fold up a parabola, your x-intercepts should touch. Okay? Like when you fold it in half, the x-intercepts meet. Okay? Just like that. Alright? So, she found what was in the middle of them. -3 is one of them. Now, here's something you need to notice, okay? Remember on that factored form, it was x minus R1 and x minus R2? That means if there's a plus sign right there, it's a negative number. And when there's a minus sign right there, it's actually a positive number, okay? So that's her two x-intercepts are -3 and +7. So -3 plus 7 is 4, and 4 divided by 2 is 2. So she knows that the axis of symmetry is going through x equals 2. That means she's found the y-coordinate, so she or the x-coordinate. So she takes that, puts it back in, and finds the y-coordinate. So therefore, there's her vertex, okay? It's 2, -12.5. So you can find your vertex in any form. It doesn't have to be in vertex form in order to find the vertex, okay? So how are these two similar? What did they both do? But how? What did they both do first? Found the x. And then once they found the x, they substituted it in and found the y. So that's the same. If you're not in vertex form, the first thing you have to do is find the x and then substitute it and find the y. Now, how are they different? Well, Christine used a formula for the axis of symmetry, and Kate just used that it's going to be in the middle, so she split the difference, okay? All right, so we did that little talk. Why are you not moving? Why are you not moving? All right, so question 5 on page 97, it says, analyze each table on the following 3 pages. Paste each function and its corresponding graph from question 2, graphing a function section of the appropriate table, then explain how you can determine key characteristics based on the form that you have been given. Okay, so the standard functions, what were the standard functions again? It was, b was a standard function. What's function b? It was something with pi. What was that one?
1/3 x squared plus pi x plus 6.4.
Okay, so that was one of them. And then, what was the other one?
F, which is x squared plus 12x minus 1.
Plus 12x minus 1. And then there's one more. There were 3 of them, right?
Yes, -5x squared minus x plus 21.
Alright, so we're going to start there. Alright, so with these 3, how can I find, if it's in standard form, we've got these 3 functions, how can I find the axis of symmetry if I have standard form, a function that looks like this? How can I find axis of symmetry on that?
Use the formula.
Okay, so I need to have x equals,
-b divided by 2x.
yeah, that's how I'm going to find an axis of symmetry. And which one is the A?
The first number beside x.
Okay, the one with the x squared. The x squared is the A. Your middle term, this is called the linear term, because if it was just that, if that was it, we'd have a line. That's your B, okay? All right, now, let's talk about the x-intercepts. Oh, okay. If you have this in standard form, you're going to have to remember back to algebra 1. Yeah. How are you going to find the x-intercepts for a function that's in standard form?
Factor.
Yes. Air 5. Boom. Yes. Factor it. And I'm sure you all remember how to factor, right?
Yeah.
What if it doesn't factor? Do you remember how to solve it if it doesn't factor? What that's called? There's a formula. Here's a hint. Like the name of the chapter and then the word formula. Yeah, quadratic formula. So if you need the x-intercepts in standard form, then you either have to factor it or you have to use quadratic formula. What about concavity? Right. If A is positive, then it's up. If A is negative, then it's down. Yeah, if A equals 0, we don't have quadratic. Alright, I'm going to move this up for a second because there's more to this chart that we need to fill in. Alright, what about the vertex? If I have standard form, how am I going to find the vertex? I think it was Christine. Was it Christine? Christine just did this. What did Christine do?
You find the value of x and then substitute it for y.
Exactly. Use your negative b over 2a to find the y value. I already told you how to find the y-intercept. How do you find the y-intercept? In standard form, which one's the y-intercept? Yeah. It's C. Okay, on 98, go ahead and write out the factored form equations. We've already gone over which ones are factored form. Because I'm going to just put the part of the chart that we're filling out. So go ahead and write out the factored form equations at the top on 98. And then I'm not going to write those down this time. But I'll give you a second to do it. Like you put the factored forms in right here, but I'm just going to show this. Alright, so who got the factored form? Kate got the factored form. Do you remember what Kate did to find the axis of symmetry? No, she didn't subtract. Well, she had to subtract because one of them was negative. But she basically found the average. Okay? So x was equal to the average of those roots. Okay? That's how she found her axis of symmetry. And then what are the x-intercepts?
The r.
Yeah, the r's. That R1 and R2. Does concavity change? No. Concavity does not change. If A is greater than 0, it opens up. If A is less than 0, it opens down. That's not going to change. Alright, now what about the vertex?
The average of the r.
Right?
And the total.
Use the average of the r's. I'm going to say roots. Times y. as far as the y-intercept, there's no easy way on this one. You have to do it the old-fashioned way. You have to substitute. Oh my goodness. Substitute. How about that? That looks better. You have to substitute your 0 for x and solve for y. This is old-fashioned y-intercept direction. Alright, so we have this chart filled out? Yep. Yep. Alright, let's go on to the next one. Ooh, it actually did. Alright, go ahead and write in your functions at the top that are in vertex form. Write those in, and then we'll talk about okay. Axis of symmetry. Anybody know what the axis of symmetry is on this one?
The line.
What's the vertex? What's the vertex? It's vertex form. What's the vertex? We wrote it down already.
What that? What is it called?
What is it called?
Number off.
Number of
Vertex, right?
K.
Okay.
Okay, so the vertex is at H, comma, K. So the axis of symmetry is going to be at x equals what? H. Yes. X-intercepts, same as the last one. You have to factor. You have to use quadratic formula. You can use completing the square on this one too, because it's kind of already completed. Concavity is the same. There you go. No trick on y-intercept on this one either. There's no like, oh, it's that. You have to substitute the 0 in for x. And solve for y. Okay, so you've got 3 charts here that are going to sort of be your best friend for the next few days. Okay, you're going to want to continue to refer back to these. So hopefully you have them written down really well. Okay. Love it when it works. All right, look at problem 2. What do you know? Nothing, right? Like, I don't. Where am I right now? I don't even know.
You don't even know.
Right? All right. So the directions say analyze each graph, then circle the function or functions which could model the graph. Describe the reasoning you use you use to either eliminate or choose each function. So even if you don't circle it, you have to explain why you're not circling it. Okay? So let's talk about this one for a second.
You can automatically get rid of some.
You can automatically get rid of some. Why? Which way does this open?
Yeah.
Down, which means what? A has to be negative, right? So what can I eliminate?
X3, X4, and X5.
Okay. A is not negative. Okay? So see, like, I can do that for these three. Every single one of these problems has to have an explanation. Either why you circled it or why you didn't circle it. Alright? Now, just because A is negative, does that automatically mean everything else is going to work? Well, I don't know. I'm going to have to check it out and see. So you might have to get a little bit more in depth with your explanations, okay?